video. So hopefully you were just watching examples 1, 2, and 3. Really, at Delta Math, we're only practicing examples 1 and 2, kind of working on how we can solve logarithms. And logarithms is going to be a new topic that is something that you guys have not seen before. It's going to be something that maybe you've done. You've actually maybe solved a logarithm, because it's really just solving for an exponent, like trying to figure out what exponent I need to get my equation to work out. So you've probably solved a log before, but didn't really know exactly that you were doing that. But a logarithm is an inverse of an exponential. So we've been talking about exponentials, and the exponentials that I'm talking about would be something like b to the y equals x. So we've got a base of b being raised to some power y equal to x. So I'm just talking about a basic exponential. A logarithm is the inverse of that. So what logarithms do is they solve for the unknown exponents. So when you're solving a logarithm, whatever your logarithm is set equal to, that is an exponent. So you're trying to find out what exponent is going to make my power, my exponential, work out and be equal on both sides. One thing that we are going to use is the power sheet. And the power sheet, I head back to Schoology here. I put the power sheet right here. I'll add it again to 7.3. I'll just keep adding that on. So you can make a copy of that, keep it in your own Google Drive. But we will be referencing that power sheet today, which reminds me I better search that up here, because that's how we can solve these exponential logarithm type problems, is we're going to use that power sheet to do that. I really encourage you to use your calculator as least as possible when we're solving logs. Now, I do kind of do a 180 when you're graphing logs. It's going to be very beneficial to use your calculator. But when we're solving logs, just to kind of get a feel for numbers in a number sense, it's going to be very beneficial for you to solve them without a calculator. It's going to help out. Mason. There is a way I can show it to you, but I would like you to not use your calculator for these. So we're going to try to solve these without using our calculator. I'm going to show you how to do that. So to solve a log, the big thing is, whenever you have a log, to solve it, you need to change it back into exponential form. And here's kind of our map. This is kind of our directions on how to change a logarithm back to an exponential, and eventually we'll get exponentials. We'll be changing them into log form, because sometimes we need to solve an exponential equation, and we're going to use logs to solve that out. But we're going to use this little map to help us convert between logs and exponential forms. So right now I have an equation in log form, and what you're going to want to do first is take this log 749 and set it equal to y. So logs are going to equal something, and that y is representing your exponent. You got to remember, logs always solve for exponents. So whatever logs are equal to, that is an exponent. So log 749, what we're going to do is we're going to rewrite this in exponential form, and you're going to probably find out, hey, I can probably figure this out pretty easily. So first, the base of your log. So this b right here in our log, in exponential form, represents the base of your power. So I have a power with a base of 7. The y, or whatever your log is set equal to, I just use a y just to keep this consistent, so that when I'm kind of placing things, I can easily see where they go. Your answer to a log is your exponent. So our answer to this log, y, represents this exponent up here. So 7 to some power is equal to, and I call this big 49 here, the x, and if we're looking at our variables over there, that's just your answer. So really, log 749, here's what you're asking it. What power do I need to raise 7 to get to 49? And you would say what? What do I need to raise 7 to get to 49? Y would equal to 2. So there's a couple ways that we could solve this out. So first is just by mental math. Second, you could go to your power sheet and you could go to the column where you have sevens right down here. And then 7 to which power equals 49? You would look, that's going to be a second power. So 7 to the second power is equal to 49. This one is pretty simple, but you might get other ones like 7 to some power equals 2401. Well, then you'd want to go to your power sheet and check out, well, what power is 7 being raised to get to 2401? So that's all we are doing to solve a log. You're just figuring out what exponent do I raise the 7 to get to 49. Answer is going to be 2. And there's going to be our result. So you can see the work shown there. You can see how they phrase it. 7 to what power is 49? That is going to be how you're solving a log. And in this first section here, you're going to see some pretty simple problems. 4 to what power is equal to 16? Okay, there it is. 4 to the second power is going to equal 16. So there's a couple of examples that we're going to be starting with. Now we will move on to logarithms that start to get into a little bit more difficulty, level 2 and level 3. So let's start taking a look at level 2. So in level 2, we've got log base 9 equals the cube root of 9. So this is going to bring back some strategies we talked about back in chapter 6. So first, log base 9. And when you're writing that 9, it's going to be smaller in there. Cube root of 9. Now we are when we're dealing with logs, we're dealing with exponents. So I'm going to rewrite cube root of 9 as an exponent. So cube root of 9 would be 9 to the 1/3. Okay, so I got log 9 of 9 to the 1/3. And then always when you're solving a log, set it equal to a variable. I just set it equal to y. That's going to be the exponent that we are solving for. Now we are going to rewrite this then as an exponential. So to solve this log out, I'm going to rewrite it as exponential. So I'm using this guideline over here. I'm going to take 9 to my unknown power. 9 to y is equal to my answer, this 9 to the 1/3. Now you take a look. Both sides of your equation have a base of 9. So how could I make both sides equal? Well, I just got to figure out what makes y equal to that, which is 1/3. So then my answer is going to be 1/3. So when I rewrite it in exponential form, I can see to get the left side equal to the right side, I would have to have my y also be a power of 1/3. And then that's going to be my result. So you can see their answers as well. They're going to rewrite it as 9 to the 1/3 power, and then you can set those bases equal to each other. They both have a base of 9, so then that would mean that my y is going to have to be 1/3. So there's how we can start to solve a logarithm, kind of in that level 2 category, where now we have to rewrite the logs, and we see that they both have the same bases when they're written as exponents, and then we can start to find the value of those exponents. Lastly would be level 2, where this is going to also be where we use our power sheet quite a bit. Level 3, sorry. Log 125, 5. So first I'm going to write this log 125, 5 equals y. And the first thing I'm going to do is I'm going to rewrite this as an exponential. So I'm going to rewrite 125 to some exponent needs to equal 5. So when I raise 125 to an exponent, I need to figure out what does it equal? What does y have to be to get a 5? And if you think about that, that's going to be going in the reverse direction. So we're going to have to figure out what y is here to go from a bigger base down to a smaller base, which if you remember back from chapter 6, is going to be some type of fractional exponent. But let's head to our power sheet. First thing you're going to want to do is you're going to get both of your powers written with the same base. So 125 and 5 are different bases right now. So I can't compare the exponent. And just for reference sake, that would be an exponent of 1. It's not written, but that would be a 1. But I can't compare their exponents until I get the bases the same. So here's where the power sheet comes in handy. So you go to the power sheet. 5 and 125 are both numbers that can be written with a base of 5. So I can rewrite 125. 125 is the same as 5 to the 3rd power. So I'm just going to rewrite it. It's still 125. It's still worth 125, but I'm just rewriting it as 5 to the 3rd. So then I would have 5 to the third 2y equals 5. And remember, that would be a 1 right there. Then power to a power, this would be 5 to the 3y equals 5 to the 1. Now, since these two bases are exactly identical now I can just figure out, well, what does y need to be to get my two powers the same, or my exponents, excuse me. So what do I need to make those two exponents the same? Well, that's just going to be taking 3y, set it equal to 1, divide both sides by 3. This is just back to our simple algebra. Y is going to equal 1/3. So we head back to put in a fraction. Remember, hit that backslash, 1/3. There's going to be our result, and then we'll get a little work shown there, and it's very similar to what we did. So what power of 125 gives you 5? We got to find that common base, and then once we find that common base, we can start to just compare the exponents. We got to get those two exponents equal to each other. That's how we can start to solve our log out. The last thing we looked at is a logarithmic scale when we did our notes. And logarithmic scales are for situations that involve really, really big numbers or really, really, really small numbers. So the example they used was decibels, but also if you're familiar with earthquakes, interested in those types of things, or tsunamis, anything that deals with like really big units of measurement, those things are actually represented in a log scale. So it's not actually the amount of units actually that an earthquake produces. It's the power, the exponent of that amount of units that are used. So when you see like a Richter scale earthquake of 7, and then you see another one happen in a different part of the world with a Richter scale of 8, they're not actually just 1 unit apart. They would be actually 30 times apart, because the Richter scale is based on powers of 30. So 30 to the 7th power would have been the one earthquake. 30 to the 8th power would have been the power of the other earthquake. So you'll see logarithmic scales just try to simplify some of those things that represent really, really, really big numbers. But that is kind of the recap of lesson 7.3, day 1. So you're going to be practicing with logs. I encourage you to solve these without a calculator. So your power sheet will have everything that you need to solve these logs, especially those level 1 logs. You'll be able to find those pretty easily. But I encourage you to use those without a calculator. Mason, as far as your question goes, we will eventually get into where that log button is. And right now, though, I just kind of want to keep it so that you guys are practicing without it. And we'll eventually get to it, and I'll show you where that is. And if you find it, great. You could probably do a quick Google search of it. That'll work, but really try to do it without. That will recap 7.3, day 1. If you're ready to break off, you can head off to work on your own.